everyone. We're going to find the intervals of increase and decrease, and also find the local max and min values, find the intervals of concavity and the inflection points, and use our information to sketch the graph. So here's our problem. We have h of x. So basically, what we're going to do to find increasing and decreasing is take the first derivative. So we do h prime of x, and you're going to do your chain rule. So that gives you 5 times x plus 1. The derivative of the inner function is just 1, and then minus 5. And you set this to 0 and solve for x to get your critical number. So you get 5 times x plus 1 to the fourth equals 5. I added 5 to both sides. Divide both sides by 5, and you get x plus 1 to the fourth equals 1. Then we're going to fourth root both sides. If it's an even root, don't forget to do plus and minus. So plus and minus fourth root of 1. So this gives you x plus 1 equals plus or minus 1. Square root of 1 is 1, but you have that plus and minus. So let's do x plus 1 equals 1. So that means x equals 0. Then we also have x plus 1 equals negative 1. So we have x equals negative 2. So these are our two critical values. X equals 0. X equals negative 2. All right. Now, let's do a little sign diagram. And put in our critical values. So we'll go negative 2, the smaller number than 0. And we're going to check our intervals. These are our intervals. X is less than 0. X is in between negative 2 and 0. And x is greater than 0. And this is negative 2, sorry. All right. So our intervals would be like negative infinity to negative 2 and so forth, if you want to write it that way. Now, what we're going to do is use our derivative and plug in some numbers. If I plug in negative 3, I'm going to get, this is going to end up being positive because of this 4 here. So if I put that in, I'm going to get a let's see. If I plug in negative 3, negative 2 to the fourth, and that's going to be, let's see. Oh, I forgot. Positive. All right, so that means it's increasing. And then let's plug in negative 1. If I plug in negative 1 here, I'm going to get 0. 0 times 5 is 0, minus 5. So that's going to be negative. Negative 5 is negative, so that's negative. And if I plug in 1, I'm going to get positive. So I just took this equation and plugged in values greater than 0 and all of that. So basically this means that it's going to be increasing to negative 2, decreasing to 0, and back to increasing. That means we have a maximum here, local max, local min here. So it's increasing from negative infinity to negative 2 and from 0 to infinity. So this is increasing. Plus, plus. And it's decreasing from negative 2 to 0. It's decreasing. So we're looking at our critical values at 0 and negative 2. So at negative 2, we can see it's a local maximum. So we do f of negative 2 equals 7. And that's going to be a local maximum. And then we do f of 0 equals -1. At 0, that's a local minimum. So local minimum. And that's it for that part. And now what we want to do is to take the second derivative of this. Take the second derivative, h prime double prime of x. That's going to give you 20 x plus 1 cubed. Then we're going to set that to 0. So I'm going to write that on here. We have h double prime of x equals 20 times x plus 1 cubed. Set that to 0. Divide both sides by 20. You're going to get 0. So that's just going to be x plus 1 cubed equals 0. Cube root both sides. So you get x plus 1 equals 0. So x equals -1. Now we do the same thing now, but what we're doing is the concave up, concave down test. So if we get a positive value, it's going to be concave up. If our derivative is negative, then it's concave down. You do your little sign diagram, -1. We're checking from x is less than -1 and x is greater than -1. So our plug-in, let's plug in -2. If I plug in -2 here, I'm going to get 20 times -3 cubed. This is -27, so that's going to make this a negative number. If I plug in, say, 0, because it's bigger than -1, that's going to make that positive. That means this interval is concave down. This means this interval is concave up. All right, so from -infinity to -1, it's concave down. And from -1 to infinity, it is concave up. So something like concave down, this is going down, and then we at some point at our -1, it's still decreasing, but it's concaving up a little. So that's what that means. Now let's find our inflection point by plugging in f of -1. When you plug that in, that's going to be at 3. So we have -1, 3 is our inflection point. And I'm just plugging things in here. I did that before I did the video to save some time. All right, I also started the graph. So basically, from -infinity to -2, we were increasing. All right, we were also increasing from 0 to infinity. We did that. Now, we were decreasing from -2 to 0. So here we're decreasing. That's all decreasing. However, our inflection point was at -1, 3. So this is concave down. It's like going down like that. And this one's concaving up because it's swinging up a little bit there. All right. And that's your graph. Thank you. Have a nice day. Bye-bye.